we have done one session on OpenFOAM, and while doing that particular session, we have understood what is the structure of files in the OpenFOAM, and we found that in a typical OpenFOAM case file, we have 3 folders named 0, constant and system. And we found that 0 folder contains the information about the boundary conditions and the initial conditions. Constant folder contains the information about the transport properties, gravitational field, and any thing about the turbulence properties. So, all the parameters which will be kind of remaining fixed, these are stored in the constant folder. And then we have system folder, and within the system folder we have multiple files. The very first file which we use is block mesh dict file, and the purpose of this file is to create geometry and mesh using OpenFOAM. The second file we saw, that was the control dict file, which contained the information about all the control parameters which are to be controlled for running the simulation. For example, what should be the time step, what should be the writing interval, what should be the CFL conditions, etc. And then we were having one file as set fields. Typically, the set fields file is used for specifying if we have to select a specific zone within the domain and we need to assign some special value of field variables to that particular zone. And then we were having FV schemes, which contains the details of all the backend CFD discretization schemes that we need to follow to run a particular case. We were having FV solution as the next file, and the idea of FV solution file is to specify solution methods, tolerances, etc. when we are actually setting up the simulation case. And the last file in that was decompose dict. So, decompose dict is typically that file is used when we want to run our simulation in multiple processors. Okay. So, say if our simulation is big, what we want to do, we want to divide the large simulation domain into small portions, and each portion we need to specify to a particular processor. In that case, if we have to run simulation parallelly, then we use the decompose dict. Now, what we will do, so after going through all the files, I have told you that within the file how we can specify all the different things, and then we have run one tutorial case which was on dam break problem. Okay. Now, I will try to show you some case of bubble rise in a stagnant liquid, in a tube which is filled with stagnant liquid. Okay. So, say if you consider a cylindrical tube, say this is the cylindrical tube and it is closed from the bottom part, and now you poured the water inside this tube, and then you allow the tube to first remain stationary, and then from the bottom part you have injected some spherical bubble. You have injected some bubble. Of course, whether it will remain spherical, elliptical, or it will acquire any other type of the shape, that will be depending upon the amount of volume we injected and what is the resultant forces which are acting on the system. So, initially if you see, bubble will be stationary, but it will be subjected to buoyancy force. So, once it is subjected to buoyancy force, it will start rising in the upward direction. So, once it is rising in upward direction, slowly it will be displacing some amount of liquid which is coming ahead in its path. So, when it is displacing the liquid, that there will be relative motion in between the liquid and the bubble interface, and we will be finding some resistance force because of the finite viscosity of the liquid and gas will be coming, which will be imparting some amount of drag force on this. So, ultimately, initially the magnitude, because typically drag force is nothing but proportional to or equal to CD times half rho v square into A. So, that is the formula for drag force. So, initially when bubble is stagnant, velocity is equal to 0. So, drag force is 0. So, entire force which is acting on the body, that is only the buoyancy force. So, because of the buoyancy, it will start rising. Once it is started rising, its velocity will keep on increasing, because initially buoyancy force is greater in comparison to drag force. So, if the force which is driving, that is of larger magnitude than the force which is restoring, in this scenario we will be finding that bubble will accelerate. What is the meaning of acceleration? As it will start moving in upward direction, its velocity will keep on increasing. But when the velocity is increasing, parallelly what is happening? The drag force is also increasing because it is proportional to square of the velocity. So, if drag force, the magnitude of the drag force is increasing, we will find a situation where buoyancy force will become equal to the drag force. Once we get the situation that buoyancy force has become equal to drag force, then we can say that the magnitude of the driving force and the resistance force are actually equal. Once these are equal, then in that case, there will not be any further acceleration of the bubble. So, if there is no further acceleration of the bubble, it means with whatever velocity bubble is moving, it will keep on continuing with the same velocity. That particular velocity in the balanced condition is something which is called as terminal velocity of the bubble. Is this point clear? And if we just reverse the situation that we take some droplet of water and we just suspend it in the stagnant environment, say inside this room. So, it will be, because of its weight, it will be falling in the downward direction. And typically we see that whatever the raindrops are coming, if there would not have been the drag force because of the atmospheric air, then the velocity of the droplet would have been extremely high and it could have even damaged the things on the earth's surface. Okay. So, typically whatever the velocity comes, we receive for raindrops on the surface of the earth, that is also actually controlled by the drag force acting on this. Okay. So, what is our aim? Our aim is that we will set up one simulation where inside the tube we can initialize a spherical bubble and we will see that how this bubble is accelerating, what are the deformations in its shape, and then what is the value of terminal velocity to which this bubble is actually adjusting. So, that is our entire aim over here. So, of course, the problem is again a two-phase flow problem. So, here we have air, outside we have liquid, both the phases are immiscible. So, in between these two phases we have some interface boundary. Okay. So, it means it is a two-phase flow problem. So, if it is a two-phase flow problem, it can be easily solved with the help of interFOAM solver. Is this one clear? So, now in interFOAM solver, typically whenever we set up any case, what is our aim? Our aim is, first we will try to take the identical case to this and we will try to modify the case files of that particular case as and when required. Okay. So, let us see how we can do this modification and what are the things we need to do. So, this is the, say, initial state when we have water filled over here and this is the air bubble. Of course, somewhere in between this bubble will be rising in upward direction and it will be having certain velocity. And while it is rising, there can be deformation in its shape depending upon the surrounding pressure field which is acting across the bubble. So, I will be discussing over here two cases. In one case, the initial diameter of the bubble is 4 mm and surrounding fluid is water having density 1000, viscosity 1 millipascal second and surface tension between air and water is 0.072 and other fluid is actually air. And the second case I will be doing where the initial diameter of bubble is 2.5 mm, but we have the combination of water and sucrose solution which is having slightly higher density than water, but its viscosity is significantly large in comparison to the viscosity of the water. So, if viscosity is significantly large, the amount of drag force experienced by the bubble will be more and ultimately its terminal velocity should be less. And the corresponding value of surface tension coefficient is actually also given. Okay. So, now whenever I will be studying the bubble rise inside a cylindrical pipe, what will be happening? If I have to do a complete 3-dimensional simulation, I have to make a cylinder, and in that I need to specify a sphere. So, typically whenever we do the numerical simulations, we know that numerical simulations requires significant amount of time, and these also involve good amount of computational resources. Okay. So, whenever we go for the 3-dimensional simulation, and ultimately what we need to do, we need to properly resolve the interface. So, across interface we must have a good amount of grid refinement, so that the approximation of the interface is proper. And moreover, I cannot do the situation that this zone I have refined, because ultimately this bubble is also displacing in the forward direction. So, what I can do, either I can make the fine mesh everywhere in the entire domain, or instead of keeping the fine mesh everywhere, I can have some dynamic mesh where mesh will be finer near the interface, and as the interface will be evolving with space and time, that refinement of the mesh will also be traveling with that, and the remaining portion it will be keep on coarsening the mesh. So, that is called as adaptive mesh refinement. But before doing all these things, this particular geometry is having one more feature, and that feature is, because of its geometrical configuration, this particular geometry is actually of axis symmetric nature. So, if you consider what I have, this is my axis. About this axis, if I rotate a rectangle, what I will be getting? I will be getting a cylinder. And if along this axis I take a half circle, and if I rotate this half circle through 360 degrees, I will be getting nothing but a sphere. So, what it means, this situation is nothing but symmetrical about the central axis. If it is symmetrical about central axis, what I can do, instead of defining the entire pipe as my simulation domain, I can only define this rectangle as my simulation domain. And if I define this rectangle as my simulation domain, whatever the value of velocity, field and interface profile I will be getting, I can simply rotate that entire through an angle of 360 degrees to get the complete interface as well as the velocity profile. Okay. So, it means this problem is giving me one geometrical advantage, that instead of doing the complete 3-dimensional simulation, which may take say good amount of time and resources, I can simply do a rectangular case, and in this rectangular case actually what I can do, I can easily solve with less resources and less computational cost. Okay. So, but the important point is, whenever I have shifted from this complete pipe to axis symmetric domain, one of the thing has happened. So, here if you see, this was earlier a wall type boundary condition, impermeable solid wall, it has remained impermeable solid wall. There is no change in the top and bottom portion of the tube, but when I will be creating a rectangular domain, I will be getting this one left boundary, and this left boundary is in reality, it is not the physical boundary of the domain, but it is some artificial boundary which is coming because of the geometrical configuration. So, what we need to do to this particular boundary, we need to specify the appropriate boundary conditions. Okay. So, if the situation is symmetric, situation will be symmetric only when no flow can cross the axis of the pipe. Is this point clear? If there is crossing of the flow across the axis of the pipe, then situation cannot be symmetric about its axis. So, one point is very clear, that at this boundary the normal component of the velocity has to be equal to 0. Is this point clear? So, normal component of velocity has to be equal to 0. And in the scenarios, if I say situation is symmetric, what it means? It means that if somewhere in the right side of this boundary I have this much velocity, and at this boundary I have this much velocity, then on the left side of the boundary I must have this velocity, then only situation will be symmetric. Is this point clear? So, ultimately what I can say that when I am moving in, if say this is my tangential direction, whenever I am moving in tangential direction, if I calculate the gradient of velocity field in right side, then also it should give me the same slope, and if I calculate this gradient on left side, then also it should give me the same slope. So, it means the gradient of the velocity field will be actually symmetric about this particular point. So, if it is symmetric about this particular point, I can say that my value of velocity in tangential direction with its gradient has to be equal to 0, because profile will be symmetric. So, because of the symmetric profile, this gradient will be equal to 0. The way velocity is symmetric, in the similar way, pressure and all other parameters have to be symmetric, then only my situation will be purely axisymmetric. So, I cannot say that one of the field variable is actually meeting the requirement of symmetry and other variables are not meeting. If this is the situation, then I cannot say my situation is purely axisymmetric. Is this point clear? So, this will be the slight change in boundary conditions. So, now it means that if we have to make our simulation domain, we have to simply make a rectangle as our part of the simulation domain. Okay. However, whenever we go into the OpenFOAM, because of course whenever we make a software, it is made always for the general purpose. It is not like for axisymmetric simulation there will be separate source code, for 3-dimensional there will be separate source code, or for 2D simulation there will be separate source code. So, always softwares are developed in such a way so that with minimum amount of the code, basically softwares are nothing but optimized code. So, with minimum amount of the source code we can do as much task as possible. So, that is the reason whenever we will be defining the mesh for axisymmetric domain, what OpenFOAM does, it actually uses the same block mesh dictionary. So, it uses the same utility for defining the mesh, and we know that same utility which is typically used for a 3-dimensional case. So, in that utility we know that when we define different blocks, what we do, we use one command hex. So, we define hexahedra. Okay. But in a 3-dimensional case, we will not be having hexahedra. So, what I can do about the axis of symmetry, I can take a wedge portion of the domain. What I have done? I have taken a portion which is having some amount of theta. So, this rectangular plane, but that rectangular plane, instead of rotating through complete 360 degree, it is rotating to some finite value of theta. Okay. Now, if I take in this way, what I can do, typically a hexahedra is having 8 vertices. Okay. So, what I can do here, I can define 4 vertices as 0, 1, 2, 3, 4, and the backward points will be having 5 and 6. So, I am having only 6 vertices, but for hexahedra to form, what I can do, first I can give the indices as 0, 1, 3, 4, which will be taking the front face. Then for taking the back face, I can take 0, 2, 5, 4. In this case, these origin points on the axis, these will be actually coming common. So, once these are coming common, these, instead of forming a hexahedra, this will be forming a wedge-like structure. And on this wedge-like structure, now because I need to solve only the axisymmetric solution, So I will be doing grid refinement only in this zone, and in the angular direction I will not be doing any grid refinement because I need not to solve the flow in the angular direction. And along with that, typically when wedge is created, the value of theta is kept less than 5 degrees when we are doing the axis symmetric simulation. But if we have to tell that, we have to also tell to our solver, because it may so happen that we may need to even do in certain cases simulation over a wedge. So what I can do, I can tell my solver that I don't want to solve the solution in angular direction. For that purpose, I will be selecting the front boundary and the back boundary, and to these two boundaries I will be specifying wedge type boundary to tell my domain that I am interested only in the solution on a rectangular plane. Is this point clear? So now with this knowledge, what I can do, I can go to my block mesh file of, dam break problem, and in that block mesh file I can do the modifications which I have listed in the next slide. So here you can see what is the type of the domain. You see it's a wedge like structure, and in this wedge, this is axis of symmetry, this is side wall, this is top wall, and this is bottom wall. Okay, and I need to specify how many vertices to define a wedge. How many vertices are needed? Already I told you 6 vertices. So first point I have taken over here 0, 0, 0. Second point is 0.005, then 0, and then minus 0.00008. What is this minus 0.0008? So typically I have 0.005. What it means? From this point to this point I have how many mm? 5 mm. So radius of the tube is actually 5 mm. Okay, let me draw the coordinates. What is first vertices? Say this is my number 0, 0, 0, 0. What is the next one? 0.005. So in x direction I am moving 0.005. In y direction I am keeping it 0, and in z direction I am moving minus 0.008. So say this is my direction y, this is direction x. So in x direction I have moved something. This is my point number 1. All are clear? However, this point is not exactly on the same plane, but it is somewhere in the back plane, negative side of z. If I say this is my z direction, then this point is shifted in the negative direction of the z, slightly shifted in negative direction of z. Is this point clear? Then what is my next point? That is 0.005, 0.000, and then 0.00. It means identical to this, but now slightly shifted in which direction? Positive side of z. So this is point number 2. What is point number 3? In y direction I have moved minus 0. So it means I have gone somewhere in the downward direction, and this is my point number 3. After that, what is point number 4? This point slightly shifted in backward z direction. So this is point number 4, and point number 5 is this point slightly shifted in forward direction. All are clear with this point? Now what I am having? Blocks. In the blocks, hex command is written, and it is written 0, 1, 2, 0. So 0 to 1 this, then 2, and then 0. I have got the top face of the wedge. What is second? 0, 3, 4, 5, 3. Sorry, 3, 4, 5, 3. 3, 4, 5, 3. I have got the bottom face of the hex. What ultimately it will be doing now? It will be joining the top and bottom face by just joining the corresponding points. Is this point clear? Now, how I have decided this coordinate 0.00008? If I take the radius, how much? 5 mm. I can keep that with reference to this point. My half angle is 2.5 degrees. By just keeping half angle as 2.5 degrees, I can calculate how much this shift I need to give in the z direction by just applying the simple trigonometry. Is this point clear? All are clear with this point? So, this is how it means that if I have to create an axisymmetric simulation domain, what I need to do, all of you please can copy the dam break folder. Please copy dam break folder and paste it in the same tutorial, and you can give same tutorial file, and you can give this the name as nothing but, you can give its name as say bubble rise. All of you have understood what you need to do? You know where is dam break folder because we have already done. So, you just need to copy it and then paste it again. Have you copied and pasted? After copying and pasting, you can give the name of, instead of dam break, you can give name as bubble, B-U-B-B-L-E. Please give the name as bubble. Have you given the name bubble? Have you renamed the folder? All of you have renamed it. So, what I am asking you to do is, you can see here and then follow the similar steps. You can go to OpenFOAM 7, then you can go to tutorials, then multiphase, then interFOAM, then laminar, then dam break. Inside this you have one more dam break. You have copied this and then pasted here only, and here you have named it as, renamed it as bubble. All of you have done this? All of you have done this? Okay, now what you need to do? You open the bubble folder. All of you please open the bubble folder. Have you opened? You can see over here. Then you can open the system folder. After opening the bubble folder, you can open the system folder, and within the system folder you can go to block mesh dict. Please go to block mesh dict. All of you have entered into block mesh dict. After entering into the block mesh dict, what you need to do now, you can see in this vertices command, there are these, I have highlighted over here. These many points are given. In place of these points, you have to give the 6 points which I have specified on the slide. Okay. So, when you are giving the point, please be careful, don't delete this entire thing. If you delete this entire thing, you will be making a mistake. So, what you can do, whatever is written there, here itself you can write, keep writing your coordinates, and after you are done, then whatever remaining points are there, delete these points. Is this point clear? Otherwise, you will be doing mistake. So, what I suggest is that I will be again opening the slide. In the slide, whatever points are written, 6 vertices are written, please write these vertices. Write these 6 points in your vertices file. You need not to write this /0/1. This is the double slash is typically used for putting an comment, and this 0, 1, 2, 3 is just kept for the recalling the numbers, so that every time we need not to count. Okay. The only thing you need to do is within these brackets you need to put these 6 points. Have you done this? Please do it fast, and while you are doing, make sure that you have not made any mistake. So all of you have done? Please let me know once you are done. Okay, done. Shall we move to the next step? Now after this, what we will be doing, you can, in the same file, you can see this next portion where blocks are written. Within the block there are 5 hexes defined. Okay. So in the previous geometry we were using 5 hexes, but in the current geometry single hex is serving our purpose. So please delete 4 hexes. We can remove 4 hexes from this. Okay. In the blocks command I can delete 4 hexes, the lines which are starting with X, 4 lines I can delete, because I need only a single hex now. All are clear with this point? I need only a single hex now. Fine. And then within that single hex I need to write these numbers 0, 1, 2, 0, 3, 4, 5, 3. 0, 1, 2, 0, 3, 4, 5, 3. All are clear with this point? Zero, 1, 2, 0, 3, 4, 5, 3. Is this one clear? Done. Then you can see that in the next bracket I have written 201, 500. What it means? In x direction I need to take 200 divisions. In angular direction I will not be having any division, and in vertical direction I will be having how many divisions? 500 divisions. Is this one clear? So in next we will be writing 201, 500. It means that in the radial direction along the radius I am making 200 divisions. In the axial direction I am making the 500 divisions. Is this point clear? Have you written this 201, 500 also? Okay. After this, can you tell me what is the next step we need to do in block mesh? We need to define boundaries. Okay. So once we are defining boundaries, how many faces we have? 1, 2, 3, and this is the fourth, though this is a line, but this also we need to define because we have to specify some boundary condition at this line as well. Is this point clear? So what I will be doing now, I will be going to properties, I will be going to boundary. Have you entered in boundary? When I will be defining left wall is having only how many indices? 2 indices, 0 and 3, only 0 and 3, and these indices I need to follow the direction such that my thumb is pointing in inward direction. So 0, 3, 0, 3, this will be now pointing in the inward direction. Is this point clear? So for left wall I can simply write 0, 3, 0, 3. Maybe what I will do, I will open a case file over here where this is already defined, and you can use the same thing for defining this. Yeah, so this is the file. So first boundary, instead of left wall I have given name as, what is the name I have given? कैसे होगा? नहीं हो रहा। चलो कॉपी कर लेते हैं, मैं बता देता हूँ ऐसे भी। So these are the changes which we need to do. All are clear? This is for defining the boundaries. उसी में मॉडिफाई करते जाओ ना, जो उसमें लिखे हुए हैं।
ये ब्लॉक में डिक्ट वाले में ही ना, इसको चेंज करते जाऊंगा।
हाँ, जैसे लेफ्ट वॉल को एक्सिस लिख दो। हाँ, मतलब वो नाम ही है, लेफ्ट वॉल ही रखना चाहो, यू कैन कीप इवन लेफ्ट वॉल। Is this point clear? Have you understood? What we need to do? We need to define all the boundaries. Okay, so maybe what you can do, let's say this way it will take time. So what you can do, you can go to home. Already we have kept the file, I am just showing what are the changes we need to do, so you have got some idea. So now what you can do, you can close what you are doing. This was just to give you the feel that how we can do the modification. So I think you have got the idea. So now what you can do, you can go to home folder in your computers. You can go to, you all can go to home folder. Have you entered into home folder? Then there is a folder Gyan course, Gyan case. Have you got into folder Gyan case? You see there will be two folders, one is case, one is case 2. So first you can click on simply the case folder. Enter into the case folder. If you enter into case folder, you may find one more case, then again double click on this, you will be finding there 0 system constant. Now go to the system, go to system folder in this and open block mesh dict. So whatever the modification I was suggesting you to do by your own, that is already done in that file. Is this point clear? So all of you can close the file and you can again enter into the main case folder. Please close the file and again enter into main case folder. Are you there in the case folder where 0 system constant is there? Are you there? Now please right click on that, right click in some blank space in that area and click on open in terminal. By just doing right click, click on open in terminal. Have you done? Now you have to type command OF7, small o, small f and 7, 7 as number. Have you typed OF7? Enter. After that, please type command block mess, BLOCK small, capital M and then ESH. Have you typed command block mess? Something has happened. Now you can type command check mess, CHECK in small and capital MESH. So you can see the mess quality, it will be telling how many number of divisions it has done. All of you are able to do up to this point? Now you need to type the command paraview, 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 and then you need to put a space, you need to type this command. Please type the complete command, otherwise you will not be able to visualize. So after paraview, do not press enter. You have to write paraview space, then hyphen and then touch, TOUCH. Okay. So those who are not able to follow, you can see here what I am doing. I have done right click, open in terminal. After open in terminal, I have written OF7, done. I have written block mess, done. I have checked the quality of the mess. My mess check is done. After this, what I have written, paraview space hyphen, hyphen is this, sorry, dashed sign, okay, and then I will be writing TOUCH, touch. Is this point clear? Now you can go to file. After paraview is opened, you can go to file, and in file you can go to open option. Please go to open option. In the open option, you have to select this files of type all files. In case of files of type, you have to select all files. All files. After all files,
पैरावी की जगह पैराफॉर्म टच है।
अच्छा पैराफॉर्म टच है इसमें।
हाँ, एक बार पैराफॉर्म टच कर दो तो वो फोम डॉट फोम वाली फाइल बन जाएगी।
So all of you, please, you can close your window and instead of paraview touch, you can type paraform touch, PARA capital FOAM hyphen touch. अच्छा ये नीचे हो गया। Please, you can close the paraview window and instead of writing paraview hyphen touch, close the paraview window. This will not work now. Okay, you have done. You have to write paraform hyphen and touch. Once you have done paraform hyphen touch, then simply type paraview. Now simply type paraview. All of you please now simply type paraview. Now paraview will be opened. Go to file, open, and here you have to select all files. You will be finding case.openform file is generated below 0 system constant. You click on this, click on OK, and inside you have to select OpenFOAM reader. Inside which type of reader? Because paraview is a post processing software, it can be utilized for post processing files of different type of solvers, and each solver has specific pattern of writing the files. It can record according to that particular pattern. So we are reading a OpenFOAM case file, we have to select over here OpenFOAM reader. Is this point clear? All of you have clicked on this, then click on OK. Clicked. Have you clicked on OK? Now click on apply button. Are you able to get the wedge? Now what you can do, you can check the mesh whether properly it is defined. So you can do surface with edges and then you can zoom in, because mesh is very fine. So you can zoom in and you will be finding that in the angular direction we have not done any grading. All are clear with this point? All are able to visualize this? Okay. We have created geometry and mesh. What we need to do now? What is the next step? We need to define initial and boundary conditions. Okay. So I have closed paraview. I saw that my geometry is properly defined. After closing paraview, I again entered into the system folder. I again entered into the main folder, and here I will be opening which file? 0 file. Okay, and in 0 file I need to first specify boundary conditions for alpha field. When I will be specifying for alpha field, I will be going to the file alpha.water.org. Please open this file. Have you opened the file? Have you opened the file? Now you can see that what is first boundary? Axis. At axis boundary, the mathematical condition should come as the symmetry condition. Okay. For that, keyword is type empty. Once we defined type empty, automatically it will be considering that this is nothing but my axis. Is this point clear? After that, I have side wall. At side wall, what will be boundary condition? 0 gradient. We have already seen in the previous case, like that it will be 0 gradient. At again bottom and top wall also, like bottom wall is bottom and top wall is atmosphere. Bottom and top wall also boundary condition will be same. How we are getting these boundary conditions we have discussed in the previous session. Okay. So these will be remaining 0 gradient. And front and back. So if you recall, in the previous case we were writing default faces, the faces along which we were not interested in solving the solution, we were writing just default faces. But in the current block mesh dictionary, we have defined front and back faces as well. So that's why I am specifying their name, front and back. And if you recall, I told you, for doing a 2D simulation, the direction along which we do not want to do computations, we specify type as empty. But if in axisymmetric simulation along the wedge I do not want to do computation, I specify type as wedge. Okay, is this point clear? So for axisymmetric we specify type wedge for the faces which are along the angular direction. All are clear with this point? So it means my And other than that, you can see at the top dimension is 0, 0, 0 because alpha is a volume fraction, dimensionless quantity, and internal field is 0. What it means? Everywhere my alpha value is 0 within the domain. All are clear with this point? Then I will be going to which file? First, let us see the U file. So, if I go to U file, dimension will be MLT. So, M0 L1T minus 1, internal field, because everywhere internally velocity is 0 and velocity is a vector field. So, internal field uniform being a vector field 0, 0, 0, and then axis will be empty, all the walls will be no slip type. Is this point clear? So, what we are doing, we are considering a closed tube. So, it means top is also closed and bottom is also closed for the given tube. All are clear with this point, and front and back is wedge. Let me go to pressure file. In pressure file, in MLT format, we have dimension of pressure as 1 minus 1 minus 2. Pressure is a scalar quantity. Everywhere within the domain we are specifying internal field uniform 0, and then axis has to be empty. Side wall, bottom, atmosphere, everywhere we are defining actually fixed flux pressure 0, because we defined the condition for velocity. Once velocity is defined, pressure will be a Newman type boundary condition and it will be solved by the pressure correction equation. Okay. After this, what we need to do? After this, we need to tell our domain that where is our bubble. Okay. So, to specify that, I will be going to system folder. In the system folder, please go to set fields file. Have you gone to set fields file? Have you gone to set fields file? Entered? In the set field files, you can see default field variables. Okay. And in default field variables, we have this line volume scalar field value. What it means? Within the entire volume of the domain, what value of volume fraction I want to specify. Okay. So, what I am writing that default value of alpha dot water should be 1. So, in place of that I have written actually, after that I have simply written 1. What it means? My entire domain will be given value of volume fraction equal to 1. And as I am doing this for alpha dot water, what it means? It means that my water is the primary phase for which volume fraction will be 1 and air is the secondary phase for which volume fraction will be 0. All are clear with this point? Then you can go to the next command, that is reasons command. If you recall, in the reasons command we specify that where we want to give different value of field variable. Okay. Earlier, if you recall, for dam break problem we used command box to cell. Now, what we want to specify? We want to specify sector of a sphere, because our domain is a wedge, and in the wedge, if sphere is there, that will be becoming a sector of a sphere. So, I will be using command sphere to cell. Is this point clear? And typically for defining a sphere, what we require? We require radius and the point about which I want to rotate that radius to define the sphere. So, it means I will be requiring center of the sphere and the radius of the sphere. So, when I am using sphere to cell command, I have specified center and written 0, minus 0.017 and 0. So, if you see, my domain was extending in the vertical direction up to minus 0.2. So, somewhere slightly above the bottom wall, I am defining center of the sphere. All are clear with this point? And then the radius of the sphere I have defined as 0.00125. What it means? My diameter of the sphere will be 2.5 mm. Diameter of the sphere will be 2.5 mm. All are clear with this? All are clear? Now what I will be doing? So now you can see, if you have to modify the case file of dam break problem, you need to do these changes. First, in volume scalar field alpha dot water, you need to write 1, and then instead of box to cell, you need to use the command sphere to cell. And where you can get these details, that what type of options are available, you can open the website of OpenFOAM, and there you can find that under set fields what are the options available for defining different regions. So you may find some option cylinder to cell. There are many options available. Okay, so you can find all the options which are written over there. All are clear with this? Now what I need to do, I will be again going to the terminal. If you have not closed the terminal, previous one, please open it. In case you have closed, you have to again open the terminal and then first write the OF7 command. Okay. In this terminal, now what I will be doing, I will be writing set fields command. So how we write? SET in small, F capital, and then fields. And typically what you can do, if you simply write SET small and capital F, and after that if you just press tab, it will be showing the full command.
Sir, in alpha.org, this internal field uniform 0
Means everywhere we have given that alpha is 0. Here, that's why there later on we specified alpha dot water default value as 1.
Okay, but what if we give 1
Then we need not to use that default line there.
that set field
Yes, yes. So we can give here 1 here as well.
here?
Is this point clear? Now what I will be doing, I will be running this set fields command. Once I run this, I am getting the message that a sphere is defined whose center is this and radius is this. So it means, and in this sphere I have set the value of field. Is this point clear? All are clear with this point? Now what we need to do next? Please tell me, what is the next step? What is the next step? Before that, we need to specify properties. We need to specify properties. For specifying properties, we will be going to constant folder. In the constant folder, I need to define gravity. So you can see gravity is in which direction? Y direction and negative y direction. So I must write minus 9.81 at the center, because this is a vector field. Okay, this is a vector field. So in the center, I must write minus 9.81. Then I will be going to transport properties. So initially I have water air system only. So when I am working with the water air system, my properties will be almost remaining the same. Or maybe I think I have opened the case of probably sucrose and water. So you can see whichever case is actually open. So I think this is sucrose and water. Okay. Sorry, sucrose and air. Water, sucrose mixture and air. And surface tension is 0.074. Is this point clear? Now after this, I will go to turbulence properties, and simulation type is laminar. I need not to do anything because this is a low speed flow. I am not interested in turbulence. Okay. After this, what I need to do? Typically, in the system folder, majorly we only either do modifications in control, dict and decompose other than set field. Okay. Majority of the settings we try to keep same only. In case you have good understanding of CFD schemes and you want to improve your simulation in terms of accuracy and computational time, you want to optimize, then you can choose different schemes as well. Sometimes it may so happen that the default schemes may not work for a particular problem. There also you may have to choose some other schemes, but for that you must have the knowledge of computational fluid dynamics. Yes. So if you see the theory of the CFD, you will be finding that for advection term, if I use central difference scheme, it will be making solution unstable. But if I use upwind differencing scheme, it will be working fine. When I have flow that flow velocity is parallel to the boundaries, then upwind will be working fine. But if I have flow across a corner, then upwind scheme will give significant numerical diffusion and oscillations. Then we have to go for TVD scheme. So depending upon the nature of the flow, we have to accordingly choose the schemes. Okay, so now I will be going to control dict. In control dict, I have to tell that from where to start. So I have written start from latest time. What it means? Earlier it was start from. Time was written start from start time. But now it is written latest time. You know the difference between the two, already I have communicated. So latest time means that whatever the existing folder is present, from there it will be starting the simulation. So existing folder is 0, so from 0 simulation will be starting. And then end time, I want to stop my simulation at the end of 1 second, so I have written 1. What is my time step? Now you can see delta t I have kept 0.0001, 10 to the power minus 3. Okay, so because whenever bubble will be evolving, my mesh is also fine. Okay, at the same point of time, mesh is fine. In comparison to dam break problem, mesh is fine. So I have to take accordingly the small time step. Moreover, whenever bubble will be evolving, it's a curved geometry, it may have significant deformations. So we have to move in a stepped manner, yeah, so that the jump across the interfacial cell is not large. Then adjustable runtime, you know already the meaning, and then write interval, after how many seconds, yeah, after what interval I need to write the data. So I am choosing 0.005 because the simulation, if I choose small time step, I will be able to observe the deformations, whatever the minor deformations are taking place, and whenever I will be visualizing it in the form of a movie, it will be coming almost a continuous thing. If I take large time steps, then in my movie there can be jumps, finite jumps. Then write format, earlier you can see it was, purge write is 0 because I want to keep all the files. If I am only interested in the output final file, then I will be going for this purge write option equal to 1. Write format, earlier you can see the format was binary, now we are writing in ASCII format. So it allows different formats. Write precision 6, everything is 1, all the CFL numbers are 1, and during the runtime we are allowing time step to be modified, and the CFL number for both momentum equation and advection equation of volume fraction is 1, and at the end maximum value of delta t is 1. So even if CFL condition, because of the modifiable runtime option, gives you very large time step, then also we are restricting that should not cross equal to 1 second. So this is the final thing which we were supposed to do. After this, what I can do, I can go to terminal and I can run command interFOAM, INTER with small, then capital FOAM. Is this point clear? Now please Press enter. You will be finding this simulation has started running, and of course it's a fine simulation. Okay, so we have good number of grid sizes. It will be taking some good amount of time.
So among ASC, II and binary, which will accumulate more space?
ASCII may accumulate, but it provides advantage that we can read these files in order to extract text.
Okay, so for
So
that
safe
we can
numbers
also
are.
make a log file also.
Yes, yes.
And so is adaptive is recommended for 2D or it's not for 2D?
No, it's not for 2D. 3D.
So for 2D we
In
can go to
open,
the maximum refinement. There is
yes.
no need for 2D.
In OpenFOAM, it means sometimes it is recommended also, but I think in OpenFOAM it is not there for 2D cases. So it is, yes, code is only for 3D. And moreover, for 2D it is not much recommended, because adaptive in every time step it will be doing remeshing, then finding and coursing depending upon the interface position. That also takes time. So in a 3D simulation, because that time will be relatively small in comparison to the overall computation time which we are saving because of using coarse mesh. So for 3D still it is workable, but for 2D case, because number of meshes are less, and so this adaptive mesh refinement may add additional uh, additional time which is being taken from every time defining the mesh. So because of that, in place of gaining advantage, it can be disadvantageous in terms of computational time,
So 2D we can go with the maximum refinement. And
because 2D is bit faster.
But accuracy will save if you don't consider the time.
If we don't consider
Time.
okay, accuracy always best to have the fine grid everywhere. So that is always best, because in adaptive scheme we define some parameters. So adaptive scheme will always involve some additional interpolation steps. What will be happening? Say if you have somewhere a fine mesh. Now if interface went from this, you will be defining a big cell. When the data from value of variable from small variable to big variable you will be defining, you will be performing some interpolation operation. In some portions your mesh in the previous time step was coarse, but in next time step it is fine. So when you will be changing data from coarse to fine, again you will be doing interpolation, some mapping to define the variable. So that will also introduce some additional error. So adaptive is means whenever like we do not have resources, then go for this.
And so right now like we are running the simulation. So what are the variables it will be saving at the back?
UVW, all three components of velocity, alpha, volume, volume fraction, and pressure.
So can we remove some parameters which are not required, like pressure?
Yes, so typically this is the by default writing format. If you have to remove that, you have to go to source code, and there you have to select the appropriate variables.
Source code means that
SRC file.
SRC.
So in SRC you have to find the portion of the code where that command is written, which is writing output. In that command you have to do modification. So there, instead of calling now the all variables, you may remove pressure variable from there, then it will not be writing.
Yes, sir, because at every write interval it will be saving, so maybe it can acquire more.
Yes, space it will be taking and time. That is the reason whenever we do simulations, we don't ask, it is not recommended that we should save data at every time step. So data we save after good number of time steps. Rectangular?
If the domain is rectangular,
Rectangular, yes, you can make, but ultimately you will be finding that rectangular geometry is actually unstable.
because this is cylindrical, so the wedge is completely rotated.
So rectangle is good, na? If you define a rectangular, it will be a cylindrical ring. Disc, sorry, not ring, but disc. It will be in 3D. If you have a rectangle, you are rotating, so it will be becoming a disc. Okay, so probably the grid is very fine, it will take time. So what we can do, instead of waiting for this, it has created good number of files. So what I can do, I can again I can keep this terminal running and I can enter into the main folder, and here I can click on one new terminal. So what I have done here, I have opened a new terminal. Now through this new terminal I will be again writing OF7, because it's a new terminal I will be writing OF7. After OF7 I can write here paraview. Home folder, sorry, not home, that case folder where 0 system constant are there. I can right click and I can open a new terminal. There I can type OF7 and after that I can type paraview. If you open this, it is bit heavy now because simulation is parallelly running and we are doing post processing also parallelly. What I suggest is, because it's bit heavy, so I suggest you can close the previous terminal and keep it open, then it will be bit faster. So whatever the previous terminal is there, where case is running, please close it. For closing this, first you can press Ctrl C command and then you can close it. So previous terminal you can open and you can keep running the paraview. Please stop the files because otherwise it will be difficult to visualize. अल्फा कर दो प्रेशर की जगह. I think most of you have got it. My system is slow. You can run the movie. चली ना थोड़ी सी. So you can click on play option and you can run the movie. So maybe whatever the output files are there, it will be sliding slightly. It will be slightly rising in upward direction if you click on play option. So you will be finding like this, it will be running few steps, it is actually rising in upward direction. Okay. Here you can see that what I have done, I have basically computed the average velocity of the bubble, and that average velocity of bubble is plotted as function of time. So here you can see initially there is acceleration phase. After the acceleration phase, bubble has got some value of velocity, but after that it is not very uniform, it is slightly oscillating. The reason is air and water are relatively having less viscosity in comparison to air and water sucrose solution. So with less viscosity, dampening of the interface will be less and interface will be having some oscillations. So because of these oscillations, even during the steady rise period, there will be small fluctuation in the velocity. However, if you average out this velocity in the steady phase for large time interval, it will be giving you the almost averaged value of the terminal velocity. Is this point clear? On the other hand, when the same simulation is started with say bit higher viscosity, there you can see that the oscillations are actually less, because of the more viscosity, interface oscillations will be less. And here you can see these black points are corresponding to experimental data, and red points are corresponding, red line is corresponding to the simulation. And probably let me check if I have the, so these are the different regimes, breakup regimes of bubble, which you can actually observe different shapes depending upon the values of Idvos and the Galilei numbers. So of course this is a bond number which represents the relative importance of body forces and the surface tension, and this is about the body as well as the viscous forces. This is again a droplet simulation, maybe I am not discussing at the moment, but what I can do, I can see if I have movie here. No, I do not have movie. So if you make the proper movie, you will be finding that this drop, while it is rising, it is kind of becoming elliptical. Okay, so it is getting compressed from top and bottom, and rather than becoming a perfect sphere, it has become ellipse. So this adjustment of the shape of the drop is a combined effect of surface tension forces, drag forces, and the inertia and buoyancy forces. So all the, okay, so if I go to case 2, all of you, if open case 2, there is one animation, anim underscore case 2 dot avi. So if you open this, here you can find so when this bubble is rising, its shape is deforming, and from sphere, perfect sphere, it is acquiring kind of a spherical shape, sorry, elliptical shape. Okay, so ellipsoidal shape it is having.
So the plot that you have made between the velocity and time, so for that you have tracked the centroid.
Yes, either I can track centroid or I can take average value of velocity within the bubble.
Okay.
I can give cutoff value that alpha less than 0.5 or less than 0.9, which will be representing purely the air domain. Just give me, ParaView will be giving you velocity, average velocity only in that portion. So that post processing you can do in ParaView.
Okay, and sir, you have plotted at all the
Times, yes, wherever I am.
0.0012.
0.005, 0.005, because our writing interval is 0.005. So I can only post process the files which I have written.
Okay, so it's not at the specific point, you have taken all the intervals.
All the points from 0.005, yes. That then only it is able to show initial acceleration phase and then a steady rise phase.
So once we get the centroid, so it is recommendable to use central difference or backward difference for calculating the velocity.
Just velocity. It is better to go for central difference because order will be higher. Order will be higher. Yes. Means order of accuracy will be higher, error will be less. Okay, so maybe with this case we will be closing this session. So we are done with the last session of this course, and now we will be having some post course things. So all of you please join in SMME conference room where we can actually start with other formalities. Yeah.